What is wrong with theoretical physicists? My name is Ann Yu. I am the narrator for these slides by Professor TSU. Here is Professor's presentation in his own words. It is a pleasure for me to give this presentation about this revolutionary topic. Before I get started, I would like to make a couple remarks. First, a scientist's dilemma. Should he bury himself within the timeless science and thrive, or should he change to temporal science in light? Second, as a learner, we gradually lose independent, logical thinking and opt to accept the approval of others. This slide shows the essence of a price. On the left-hand side, we show an empty, timeless space. It has no time, for which it has no price to pay. On the right-hand side, it shows a temporal space. It is compacted with substances, and it does have time, in which we see that within a temporal space, there is always a price to pay, an amount of energy, delta E, and a section of time, delta t, and it is not free. This slide shows a temporal universe in which we see that the boundary of our universe is expanding at the speed of light. On the right-hand side is shown a subspace in which we see that it is filled and compacted with substances, and the subspace changes with time. Every subspace was created by an amount of energy, delta E, and a section of time, delta t. This slide shows 5 of the most elegant, simple equations, which are entropy, information, uncertainty, relativity, and temporal subspace equations. But all these laws and principles were developed from a timeless subspace platform, t equals 0, except temporal subspace. Nevertheless, these laws are actually uncertainty principles, since all of them change naturally with time. In other words, without the existence of time, we would not have this set of laws. This slide shows the nature of delta t, in which we see that all the 5 elegant principles are associated with a section of time, delta t. This slide shows a set of Big Bang creation paradigms. On the left-hand side, it shows that a gigantic mass is embedded within an empty space paradigm. Since substance and empty space cannot coexist, it is not a physical realizable paradigm. The right-hand side shows a giant mass is embedded within a temporal space. This is a physical, realizable paradigm. Thus, we see that over time, a huge gravitational field induced by mass is established to ignite the Big Bang creation. In other words, without gravitational field induced by the mass, it has no way to ignite the Big Bang creation. We also see that it must be the gravitational force that triggers the Big Bang creation, instead ignited by time as commonly believed. This slide shows Einstein's special theory of relativity. On the left-hand side, it shows that Einstein's special theory was developed within an empty subspace. This means that his theory is directional, independent. However, if special theory is developed within a temporal space as shown on the right-hand side, we can show Einstein's special theory is a directional theory. This slide shows the dilemma of a photonic traveler at speed of light. We assumed the traveler is circling around the world many times to achieve a time gain. But as I have shown in a previous slide, special theory is relativistic, directional, within temporal space. Although the traveler has the advantage of traveling at speed of light, the photonic traveler would not gain any time after all. One of the most intriguing paradoxes in modern physics is Schrödinger's cat, as shown in this slide. Since the box contains a timeless radioactive particle, we see that it is not a physical realizable paradigm to hypothesize. We can show that Schrödinger's cat is not a physical realizable hypothesis. This slide shows a newspaper's clipping published by New York Times in 1935. It showed that Einstein and his colleagues found quantum theory is not complete, even though correct. But as I see it, superposition principle is correct, but only within a timeless subspace. It is incorrect within our temporal space. This slide shows the general theory of relativity. Since within temporal subspace, time coexists with subspace, time is a dependent forward variable. Then a question is, can we curve space-time? The answer is that since our universe changes with time, it is not our universe that changes the time. In which we see that since we cannot change the speed of time, it is time-space curves with time, and it is not time-space curves the time. As John Wheeler had said that, and I quote, "Space-time tells matter how to move. Matter tells space-time how to curve." However, as I see it, it is time that tells space how to curve, not space telling time how to curve. The paradigm shown in this slide illustrates how time curves a subspace. However, we can move time backwardly. Then we see that it is the space that curves the time. But the thing is, we cannot run time backwardly. And this precisely is what general theory did, since the theory has treated time as an independent variable. This slide shows a possibility for timeless quantum entanglement. Since Pauli exclusive principle was developed on an empty space platform, it is a timeless principle. On the left-hand side, it shows a timeless universe. Since it is timeless, then the entanglement is instantaneous. But we are not living within a timeless universe. On the right-hand side, it shows our temporal universe, which has time in it, and it is temporal. Principal entanglement existed within our universe, but limited by the speed of light, and it is also limited by time-limited quantum state reality. Yet, my question is, what is the advantage for using quantum entanglement for communication? This slide epitomizes the nature of a temporal space. We see that the age of our universe is about 14 billion light years. The present instant, t is equal to 0, divides physical and virtual realities. Negative time domain, t is smaller than 0, represents past certainty. Positive time domain, t is larger than 0, represents future uncertainty. Within temporal, t is larger than 0, domain, space changes with time, since time is a dependent forward variable. But within negative time domain, t is smaller than 0, time changes with space, since time is an independent variable, as from a mathematical standpoint. But in temporal reality, time is no longer existing within the negative time domain. Space at time equal to 0 is the only moment of absolute certainty. Because we cannot change time, that is why we cannot travel behind or ahead of the speed of time. This slide shows a necessary condition of physical reality. In view of the present instant, t equals 0, which divides the physical and the virtual realities in the previous slide, I would say that hypothetical science is based on the past certainties to predict future outcome of uncertainties, which is supposed to be physically realizable. Otherwise, the solution will be virtual and fictitious as mathematics. Therefore, imposition of a physically realizable constraint, in other words, temporal, is a necessary condition to safeguard the solution that would be physically realizable, in which we see that science is not supposed to be deterministic, in other words, approximation. This slide shows the tale of two paradoxes. On the left-hand side, we see Schrödinger's hypothesis was within an empty subspace. On the right-hand side, we see Einstein's special theory was derived also within an empty subspace. Since subspace and emptiness are mutually exclusive, therefore both hypotheses are not physically realizable postulations. Finally, a big question is, why are practically all the laws, principles, theories, and paradoxes of science timeless and time-independent? The answer is, all the laws, principles, theories, and paradoxes were developed on empty paper for centuries and centuries, as shown in this slide. Since theoretical physics uses mathematics to hypothesize certain phenomena, it is not always realizable. In conclusion, we see that empty space undermines the physical reality of science. A score of scientific hypotheses were virtual and fictitious. Within our temporal universe, everything has a cost. An amount of energy, delta E, and a section of time, delta T, but it is not free. A remark: science is a law of approximation. However, mathematics is an axiom of certainty. As a learner, we gradually lose the independent logical thinking, and we opt to accept the approval of others. Finally, I have a few articles to share. For example, an article that we recently published on what is wrong with current theoretical physicists. The two articles on nature of temporal t is greater than 0 quantum theory. Part 1 and Part 2 will be published soon. And lastly, an article on the nature of relativity will be coming up soon as well.